Hello friends, welcome. We all know that wireless technology and telecom in general has impacted our lives significantly. The operators all over the world are using telecom technology to offer various kinds of services which were earlier not possible. But these technologies have certain capabilities which are dependent on certain attributes, and modifying these attributes changes the offering significantly. It also impacts the consumer's ability to use a certain form factor. So what I thought that it will be useful for me to explain these concepts in a simplest possible manner so that even a layman can understand. These concepts, if you have to go the conventional way, it will be very complex to understand. So I am trying to take an effort. I don't know whether I will be successful, but I'm trying to make an effort to explain this concept in a simplest manner that is possible. So today I have picked an important concept in wireless technology called antenna design and how antenna radiates. Now, after the end of this small video, you will understand that why this concept is so important for you to understand and how it kind of impacts your ability to choose a certain form factor, whether it is FWA or a mobile phone or satellite telephony disk. Those are driven by this concept. Even the BTS which are transmitting, they are all using antennas. So let's understand how antenna radiates and how it works. Now friends, what I have done is I have drawn a concept diagram, and this is the diagram which I have drawn by myself because I tried to basically go and search the web. I could not find a very simple concept diagram. So I thought, let me just put it out before you. I'll explain to you what it means. So this is a simple circuit diagram. Consider this as an electronic component embedded into an antenna, which is enabling it to radiate RF waves. So this is a source. This is actually a frequency generator. So what it will do is it will throw in this circuit a certain waveform of a particular voltage and amplitude and a certain kind of current with a frequency of f megahertz, or let's say f hertz. Now once this current flows in the circuit, I just shown pictorially how the current is going to look. It will simply go and it should follow this path and then return. So this is positive, this is negative. Let's say this is an alternate current. The positive and the negative is going to keep alternating depending upon the frequency. It's simple to understand, right? So in this diagram, you see there is an open end, means the circuit is not completing, which will look to you quite strange because normally in a circuit diagram, the circuit should complete, means it should go from one end and it should return back on the other end. But there is a gap here. Now this gap where the antenna attaches. This is the convention which every technology or every kind of implementation will follow. There will be a gap which will, what it will do, instead of terminating from this point to this point, it will terminate into free space. Now friends, free space has got certain impedance. I will define what impedance is, but let's for the time being understand free space has got certain impedance. It's almost like the impedance of a circuit. Like this circuit will also have certain impedance. What is impedance? Impedance is the resistance. Let's understand that resistance is actually a technical word, but I'm just for the sake of making it simple, I'm just calling it resistance. It will face this resistance is nothing but the opposition this current faces in the path as it traverses through the circuit diagram. So when you are traversing when the current is traversing through the circuit diagram, the resistance that it faces, the opposition that it faces in the path as it traverses is called the impedance. Sorry for that. Now, the impedance depends upon two different quantities. One is the resistive path, which is R, let's say X here, which is basically nothing but simple resistance. Another is Y, which is basically an imaginary path. Let's not get confused with imaginary and resistance. Let's assume that there are two different components. Now, this Y is made up of inductance and capacitance. I am going to explain to you what inductance and capacitance is. Now, this impedance of this particular circuit, when it matches with the impedance of free space, then only seamless propagation of RF waves happens to the free space, like the antenna start radiating the most efficiently. So it has to match the impedance of this circuit. What the circuit sees from here has to match the free space impedance. Now friends, you know, as I told you just now, that the impedance of the circuit depends upon the frequency. Why frequency? Because if you look at this Y is a multiple of j omega. Forget about j. Omega is 2 pi f, where f is embedded into omega, and then it is multiplied by inductance minus 1 upon capacitance. And you don't have to worry about these terms. Just simply understand that Y depends upon frequency. So as you change the frequency of this particular generator, the impedance will change. But the free space impedance may be, assume it is constant. It may not be constant all the time, but just for the sake of assumption, assume that it is constant. It does not change its frequency. But the circuit diagrams, what the circuit is going to see from here, let's say if you are looking from the circuit here, or what you are looking from here, it will see an impedance, and that impedance is directly proportional to, or it dependent on, not directly proportional, it depends on frequency. So as you change the frequency, the impedance will change. So at a certain point of time, the impedance will match the impedance of free space, and at that particular point of time, the radiation is going to occur in the most optimal fashion. Now, so when the impedance becomes equal to that of free space, there is one property of the antenna, which is extremely important for you to understand. For the antenna to able to match the impedance of free space at this particular port of the antenna, which is basically radiating, the antenna element has to be proportional to the wavelength of this particular signal. Means, if you are going to have a very short antenna, which is, let's say, 1/8 of the wavelength, or a very, very short antenna, wavelength is pretty large, let's assume, and the antenna is pretty small, you will not have an effective propagation. So I'll just give you an analogy. I'll come back to this slide again. The analogy is this particular water hose analogy. Now assume that you have a big water pipe, and then on that water pipe you are connecting a smaller water pipe with another water pipe with a smaller diameter. Now you push water from this pipe in this direction. What will happen? As soon as the water starts flowing, some of the water which is flowing from this side is going to hit on this side, which is not going to, it's not able to penetrate through, and therefore it will reflect back, right? Only the water which is flowing straight forward will go. So the efficiency of the flow of water is going to be restricted because of the size of this water hose pipe. Similarly, if you come in this particular diagram, go to this diagram, if the impedance is going to be higher compared to this impedance, and the current is flowing here, it is facing a lower impedance. As soon as it comes here, it faces a higher impedance, current is going to reflect back. It is as simple as that, right? Therefore, the propagation is not going to happen. So that is why you have to match the impedance, and that's why the matching the impedance needs you to consider the length of the antenna. The antenna could be of various types. So I'm basically taking a dipole antenna here. The length of the antenna is very crucial. That is why when you are operating in a lower frequency band, let's say 700, 600, 500, when the lambda size increases, the antenna size also increases. It becomes very difficult to incorporate that antenna within the mobile phone. So it becomes extremely challenging for us to deploy antenna at lower frequency in a mobile phone. Now, friends, you will be surprised to know that everybody understands that lower the frequency, better is the propagation of the RF wave. But I will tell you that it is not the case. Why? Because as you lower the frequency, because of this challenge that you are going to face of antenna design, there will be a loss that is going to happen as the signal is trying to be received by the mobile phone. So let's say at 900 megahertz band, if the loss is 0, then the propagation of 900 megahertz band is going to be dependent by the frequency characteristics of the wave. The antenna is not neither blocking nor amplifying the signal. There is no gain in the amplitude. Let's assume that it is 0. But if you are going in the lower frequency band, let's say 700, 600 megahertz band, even though the propagation of the RF wave will be better in the lower frequency band, because of this issue of antenna length, packing this length of the antenna in a shorter form factor of the mobile phone, actually the propagation will be similar to that of 900 megahertz band. So low frequency band does not give you better coverage. Because why it is not going to give you better coverage? Because of this particular problem which nobody really focuses on. So that's what I thought. Through this video, I am going to basically bring this point before you so that you understand that antenna design is very, very crucial. Similarly, in case of satellite technology or let's say microwave technology, where you see a disc, the disc is acting like an antenna. Now what it is doing, it is basically sharpening this beam and pointing this beam in a specific direction of space. By doing so, whatever power that emanates out of this particular area gets locked into a shorter solid angle. Solid angle is nothing but a small dimension of space. A sphere has got the full solid angle of 360 degree. Now if you are going to extract a small portion of sphere, then and if you put all your power which is coming out from an omnidirectional antenna within that small solid angle, let's say 30 degrees, then your ability to move a larger distance with the same power is going to be significant. That is why satellite antenna, which is basically disc based, or DTH antennas, they are able to receive signals of low power. But again, the size of the disc and the structure of the overall system is directly proportional to frequency, and is inversely proportional to frequency, that is the length, and it is directly proportional to wavelength. So basically what I am trying to say is that if you really want your signal to be of better quality, you have to increase the size of the antenna. Shortest antenna size is basically going to be lambda by 4. But let's say if you want a very good quality signal, very low noise is extremely high around you, and you are basically receiving a signal which is of very, very low power, then you have to have a disc of very large size. You might have seen this, when satellite receivers or even telescopes have a disc which is very, very significant. Now, in case of satellite broadband, why this is so important is because conventional satellite discs are of a smaller size and they have been structured in such a way that they are optimally able to receive signal without raising the cost of the disc. But if you really want the reception and the transmission to be much, much more empowering, then if you increase the size of the disc, then what happens? The uplink and the downlink data rates becomes almost same. So for you, because currently if this disk is small, then the downlink, because the satellite which is actually on the top is hanging from the sky, is able to transmit with a bigger antenna. So you will have a good downlink speed. But if your disk is of a smaller size and if you want to transmit up towards the satellite, that speed is going to decrease because your antenna is of a smaller size. So if you increase the size of the antenna, then the speed will increase, then you will have a better upload speed into the satellite. I don't want to get into inductance and capacitance. It is going to confuse the issue. I am on to basically keep the video short. It has already got 15 minutes long. So I hope that you probably have understood the concept of antenna design, why it is important. So I'll end the video here, and thanks for your patient listening.